All right, another type of exponential equation problem you're going to get is one where they give you the equation from the beginning. So we're told that we have this egg equation. So eggs equals this, and we're measuring our time in weeks this time. We've got W greater than or equal to 22, and thinking about this, a chicken would need to be at least 22 weeks old before it starts making eggs. So that's why we're starting at 22. How do we know it's decay? Well, our rate of growth, before we were doubling and that was exponential growth, now we've got a rate that's less than 1. So 0.89 is less than 1, therefore we have decay. All right, graph our model. Well, we know that we want to start at 22, and looking ahead in the problem, the egg production of a chicken that's 2.5 years old. So I don't know how old chickens live, but it's older than 2.5. So I'm going to go ahead and graph this and think about my domain and range as I'm graphing. For sure, this is a calculator problem with these numbers. So let's go into our y equals. I have, well, hopefully my calculator will work. Let's try that again. All right. Sorry. Let's get our calculator. Not even there. All right. So let's get our calculator back. All right, so we're going to use, while that's opening, we're going to use our graph, 2.5 years old, so that's going to be my x value. How old is a chicken producing 100 eggs? That's my y value. So we're going to look for those points on our graph. And let's go into our y equals. I have the equation there already. And let's think about our window. So we're going to start at 22. And I'm going to go for a chicken that's, I'm going to make it go out to at least 3 years old. So 3 times the number of weeks. So 3 years times 52 weeks. Because I'm measuring my x-axis in weeks. I'm going to count by, let's say, I don't know, to go from 22 to 156, I'm going to count by tens. My y max, well, my initial value is 179.2. I know I'm starting at 22 weeks, so I'm going to be past that, but we can use that as our y, sorry, that'll be our y max. I'm going to say 180 just for a nice even number. My y min, I'm going to go with 0 because I know this graph has the asymptote at y equals 0. And now I'm going to count by 15s. So let's look at that graph. And I can see that this graph is looking very flat. So I would need to go much further out on my x-axis if I wanted to see it approach 0. So to make it look more like that, let's go ahead and do that. Sorry. So much further out. Let's go, let's say to 500. And now let's count by 20s. And now we're looking much more exponential in our shape. We're still not hitting our asymptote. So apparently chickens take a really long time before they stop producing eggs. So let's put this graph over here and let's think back to our window. So we've got 22 on this side, 500 on this side, and those are weeks. And we had 180 up here and 0 down here, and those are my number of eggs. So if I want to use my calculator to estimate the egg production of a chicken that's 2.5 years old, well, first of all, I would need to know how many weeks 2.5 years is. And this is also me wanting to find a value from my graph. So second calc, I'm going to go for a value. My x value is going to be 2.5 years. And then I have 52 weeks in a year, so times 52. So that's going to give me my number of weeks at 2.5 years old, and that's 130 eggs. So P of 2.5 years. Remember, my input was weeks. So P of 2.5 times 52 is going to be equal to 130 eggs. And of course, you could also put that back into the equation, but W is weeks. And sorry, we're using E for our eggs. All right, I want to know how old is a chicken that produces 100 eggs per year? So that's a Y value of 100, so it's going to be further down here. I'm going to add in Y equals 100 and look for the point of intersection. All right, so that looks like it happens somewhere around here. I'm counting by 20s, so 40, 60, 80, 100, 20, 40, 60, 80, 200, around 240 it looks like. And I want to know that because if I hit my second calc and now intersect, equation 1, equation 2, oh, and look, it's super close already, so I'm just going to go ahead with that guess. All right, 260.2, so W's approximately 260.2, but at 260 weeks it wouldn't have hit, so I have to give 261 weeks to produce 100 eggs per year. Let's think about this. So if I go with 260, it would be below, sorry, if I went with 261, I'd be below 100. 259, I would be above 100. So actually, I should say 259 weeks, we're making just more than 100. At 261 weeks, we're making just less than 100 eggs per week. All right, rewrite the equation so time is measured in years. Well, notice I had to convert my years to 52 by multiplying by 52. Well, notice up here, I divided by 52. So if I wanted to convert so it was written in years, well, I did 2.5 times 52 and then divided by 52. So if I just got rid of this divide by 52, then I would have an equation that was measured in years. So E, we would have that eggs equal 179.2 times 0.89 raised to our time value. Again, this is almost always years, but when I manipulate it, I can turn it into weeks or anything else. So here we divided by 52 to change from years into weeks. And I'll give this a Y to stand for years. All right, if that's confusing, ask me about it in class and we can talk about it some more.